All right, so this lesson is going to be all about ionic compounds and ionic bonds. So let's talk a little bit about why elements combine in the first place. So we have elements, they're the most simple form of matter, um, different types of atoms, but we're not going to find pure elements out in nature very much at all. They're usually not stable that way. They're going to form compounds. Compounds are two or more elements chemically combined, so they're not just mixtures. They have chemical bonds between these elements. Okay. And in these compounds, the properties of the compound are going to be very different from properties that the elements um, themselves have on their own. So the classic example here is sodium and chlorine. Their properties are very different from the properties of sodium chloride, which is table salt. Okay. Sodium or chlorine, if you tried to eat it, would kill you pretty quickly if you got enough of it. But table salt, sodium chloride, the compound, is essential to life, makes things delicious. We have it all over the place. It's just sitting on our tables. It's not any kind of danger at all. So the the key takeaway there is that compounds properties and the properties of a pure element are very different. Okay. Okay. So we use chemical formulas to describe compounds. Chemical formulas tell us what elements are in the compound and how many of each element are in there. Okay. So an example, H2O. This H2O is chemical formula for water. Okay. Um, Chemical formula for ammonium was NH3. So for every one atom of nitrogen, we'll have three atoms of hydrogen in an ammonium compound. And if we visualize it over to the right, there's a water, H2O, and there's our ammonium, NH3. This is one of the big ahas back in early chemistry, is that these compounds, if you break them down chemically, you're always going to get the same whole number ratio of particles of elements. So water, you're always going to have 2 to 1 particles of hydrogen to oxygen in water. Okay, so why do these elements form compounds in the first place? So they form them the same reason ions form. These elements want to be stable. Okay, um, and what do we mean by stable? When we're talking about stable chemically, we're talking about their electrons being in a certain configuration, right? And the octet rule tells us that atoms will gain or lose and share electrons in order to have 8 in their outer energy level. So this oct means 8, like Dr. Octopus or um, I don't know, just octopus in general. They have 8 legs. That octo or oct means 8. So these elements want to have 8 in those outermost energy levels because that is what's going to make them stable. They want to be stable. Um, and elements will reconfigure, electrons will move until they're in a stable state. It's a lot like if you put a basketball on the side of a hill. It's not just going to stick there. It's not stable there. It's going to roll down to the bottom and it's going to keep rolling until it finds a stable spot. And these elements will do the same thing. They're going to keep moving, keep recombining until they're stable. Okay. And that stability is according to the octet rule. These elements want all their energy levels to be full up. Okay. And hydrogen, helium are a little different. All the other ones are 8. Okay. So bonds, when these elements gain, lose, share electrons to become stable, they can form chemical bonds. And chemical bonds are just a force that holds atoms together. Okay. This is the reason they're different than mixtures, because they have these chemical bonds, these forces holding the elements together. Particularly, the first one we'll talk about are ionic bonds. This is when electrons transfer from one atom to another. They completely go over there. They're not sharing this electron. The electron transfers from one to the other. Okay, this usually happens between a metal and a non-metal. Metals want to donate electrons. They want to give them up. Non-metals want to accept them. They want to fill up their electron energy level shell to complete that octet rule. So in our example here, this sodium electron should go over and fill that outermost energy level of chlorine. Once that happens, you have this positive charge on the sodium, negative charge on the chlorine. These opposite charges attract, so these two elements stick together, and that attractive force is the ionic bond between them. Okay. So ionic compounds are made of charged ions. Now, the elements, the atoms within the compound are charged, but the overall charge in the compound must be zero. Okay, so the amount of positive charge has to equal the amount of negative charge. All right. What this means is we can predict the charge of um, ions that each element's going to make. We did that on 5.2. We use the periodic table to determine what ion each of these elements will form. And if we know the charge in the metal and the nonmetal, we can predict how many of each we need to make a neutral compound. Okay, and we can predict how they're going to react. We can predict the kind of compounds they're going to form. Okay, and I'm going to give you a step-by-step process to do that on the next little video. Right.